Okay, guys, in the previous video, a short video here, okay? In the previous video, we looked at a scatter plot, and we noticed that this one kid right here, the kid on row 3, head circumference 17.75, height 25.5, seemed to be an influential case. An influential case means that there's reason to believe that if you took that kid out, that the results would change quite significantly. So I just want to take a look at that. Let's come in and take that kid out. So to do that, we know by now we go to Data, and we go to what do we go to? Go to Edit. I'm sorry. We go to Edit. We go to Row, and we want to delete. And I want to delete the selected row. Now, the things I want to do, yeah, you know, the mean. Well, I'll tell you what. Let's just go ahead and look at it all. So if I look at summary statistics and I look at, I really just care about the first 2, and I really just care about the ones I did before. And I haven't done this yet, but I can almost guarantee it's going to change quite a bit. The height didn't change much. The mean of the head circumference actually didn't change much either. Standard deviation got a little larger. That surprises me. And these things didn't change a lot either. But I want to look at the relationship. And I can do that by going to regression, and my x is height, my y is head circumference, and I just want to keep it simple here and just do a fitted line plot and go for it. Now what happens by removing that one kid, we can see that the R value, and that's really what the focus of this is all about, the R value went from 0.67 to 0.81. So it went from a moderate and positive to a strong and moderate. And the R squared, you can see, no, wait a minute, I'm wrong here. I'm looking at the wrong line. The R was actually 0.90. And the R squared was actually 80.9%. So you can see that kid was very influential in the results. Now, you know, when you get to big, really fancy, schmancy stuff, you get into things like DF fits and DF betas and Cook's distances and different things that can tap into the impact of each particular case. But that, you know, that's not what we do in this class. But I just want you to kind of have that on your radar, that you can examine your scatter plot, and if you see a point that's kind of out of whack, for lack of a better way of putting it right now, you know, removing that point can significantly affect the R squared, and so on and so forth. And even our model, we can see that our intercept was 12.87, it decreased to 11.8. And our slope was 0.17, our slope was 0.21. So there was much more, almost, 0.4, so almost a half of an inch difference in the predicted head circumference for each increase in height by removing that one child. So just something I wanted you to have on your agenda. Now, let's talk about one more thing. Let's talk about this line called residuals. And your textbook doesn't get in much to residuals. And all I'm going to do is define them for you and tell you what they do for us. A residual is just kind of the error in our model, and it's the difference between the observed Y value and the predicted Y value. A lot of times in symbols, you'll see this as y minus y hat, because again, predicted anything is just that anything with a hat over it. We talked about that in previous videos, and the observed y is what we just observed for the child. So, how to calculate? Well, the easiest way to calculate is to let Stack Crunch do it for us. For example, the first child over here we can see has a residual of negative 0.12. So the way they got that and I'm using the newer model without the kid that had that seemed to highly affect the model. So first thing we put in is we put in the observed y, and the observed y is just what we see when we collected our data. And then we predict our y. Well, guys, remember our new model predicted by taking, and I'm going to put this down here, 11.7996 plus 0.21081 times the kid's height. Well, what we want to do is we want to put in the height for this kid, which is 27.75. So I'm going to do that real quick. And I get 17.65. Now, if I take that value minus that value, you'll say, well, Dr. Darbo, you don't get negative 0.12. But guys, remember, I created this for a different model. These residuals right here were created for the other models. So if I go through now and do my regression, do my simple linear, do my x of height, my y of head circumference, to come down and choose my residual and store it, you can see that the value I get now for this model is very, very, very close to negative 0.10. Give me a little bit of slack for rounding, and it turns out to be exactly the same thing. So if I take this minus this, I get negative 0.10, and technology has it at negative 0.0995. So you can see these things are very, very close. And the only difference is I rounded off to 4 places here and 5 places there, and they made the calculations based on the entire decimal expansion out to, I'm told out to 20-some places, but I don't know if that's true or not. So guys, residual, it'll probably pop up, and I'll find out the people who watched the video and who didn't. What's the residual? It's the difference between the observed y and what our model would have predicted. They're very, very easy to calculate by hand. They're even easier to click the right line and calculate using Stack Crunch. So that's all I got in this video. Take care.